Mr. Callan here to help you with Chapter 5, Lesson 6, Part C. It's almost like Part 3. It's not really in the book, but it is a standard in the state of Indiana, factoring linear expressions. Before we get there, go ahead and pause your video, whatever the assignment number is, page 133, number 49 to 58, 62 to 70. Pause the video, check your answers, come on back when you're ready. So folks, what we're going to do today is we are going to factor linear expressions. Now, it's something sort of new, but we can connect it to something we've already done. There was a time when you were given an algebraic expression with parentheses and you were asked to distribute 3 times W, 3 times 5, then take the opposite. And we got negative 3Ws, subtracting 15. Today, we're going to go backwards. We're going to start with an expression, and we're going to factor it apart into two numbers or two quantities that are multiplied by each other. You're going to need this eventually to help you with solving quadratic equations in high school. All right. Assignment today is coupled into notes as well. That's not the right page. We'll have to get the right page up there. Let's talk about prior knowledge. What is a factor? Remember, please, that a factor is any number multiplied by another number. It does not have to be a whole number, nor does it have to be an integer. It could be a fraction or a decimal. Now, when we do factor something in mathematics, we're finding the actual factors of an expression, meaning we're looking for what was multiplied. You can almost think of it as undistributing, going in the reverse or opposite direction. Now, let's use that undistributing idea to factor the below expressions. We're going to factor it, and yes, it does say if it cannot be factored, that's what you should write, cannot be factored. All right, let's take a look at 6x plus 10. Now, the first thing I'm going to do is I'm going to write the prime factorization of 6x and 10. 6 can be broken down with a single x part of the term, and 10 can be broken down into 2 times 5. Now, very quickly, ladies and gents, you will notice that the 2 can be factored out. Meanwhile, now you have to kind of go backwards, undistribute, if you will. 2 times what number will give you 2x? Let me put that in green here. And obviously 2 sets of 1x. Think about groups. If you have 2 groups, nope, not 1x, Mr. Callan. 2 groups of 1x would only be 2x. 2 groups of 2x's would be 4x's. Ah, there we go. 2 groups of 3x's would give us 6x's. Meanwhile, 2 groups of what would give us the 10 number? Naturally, 2 1s, 2 2s, 2 3s, not quite enough yet. But 2 groups of 5 would give us 10. And so we have now factored a linear expression, 6x plus 10, into 2 factors. One of the factors is 2, and another factor is, well, an expression altogether, 3x plus 10 plus 5. If you're ever concerned about it, you can always check and go backwards. If you were to distribute now, 2 groups of 3x, 6x, 2 groups of 5, 10, both are positive times positive, and so it works out. Now, interestingly enough, some of you quickly notice if you do the prime factorization method, what's left over? 2 times 3x gives you 6x, and 2 times 5 gives you 10. You can see that. All right, let's do the same thing for number 2. 4x we can break down. I'm going to pause for a moment and temporarily act like the negative's not there. 4x can be broken down into its prime factors. 16 is 2 times 8, but 8 is composite. 8 is 2 times 4, but 4 is composite. And 4 is 2 times 2, so there we have it. Now quickly we notice that we don't just share a 2, we actually share 2 times 2, or 4. Now, remember to undistribute. We're asking ourselves 1 times what is x, is 4x's, excuse me. And I'm going to put 1 times 1x, and I guess we do need negatives. 4 groups, if you were to write that out, 4 groups of negative x would give you negative 4x's. Meanwhile, 4 groups of what would give you 16? Oh, excuse me, that would be negative 16, Mr. Callan. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. However, if I could point out, if I'm really truly getting you ready for algebra, I would argue if you can at all factor out a negative symbol, go ahead and do so. And in this case, negative 4 times 1x would be negative 4x's. And the opposite of 4 groups of 4 would give you negative 16. P.S. ladies and gents, of course, you don't have to write that one. You may simply write an x plus 4. That would be equally acceptable. All right, let's continue on with 3 and 4, and then I'll have you do a few more on your own. All right, so as we get into 3 and 4, look at how the problems are similar. Look at how the problems are different with the problems that we just did. What we're going to do is we're going to try to factor the expression 2x minus 8. And I'm going to go ahead and write a little blank here. What number are we going to factor out? And then I'll put a blank in front of the x and a blank after my plus symbol. Now, if I think about both 2x and 8, I quickly see they're even, and 2 can be pulled out of each of those. Now, 2 times what would give me 2x's? Well, Mr. Cowan, all you need is 1x, 2 sets of 1x. On the other hand, 2 sets of what would give us negative 8? You know me, I'm going to change subtraction into adding its opposite. And of course, 2 groups of negative 4 would give us negative 8. Naturally, you may write that in a different manner. You may write simply an x. Some of you don't even write adding a negative. You may write subtract if you wish. Both of those equally acceptable. Now, you may always check if you wish. 2 groups of x, 2 x's. 2 times we go down 4 means we would go down 8, and that is, in fact, what the original expression gave us. Now, for number 4, I'm going to do this the hard way. Maybe I should say the long way, because once again, we notice that both of those terms are even. So I'm going to take out 2, right? You can take out a 2. Sure, why not? So in this case, 2 groups of 8x would make 16x, and 2 groups of 12 would make 24. However, I think you'd agree with me when you spotted the fact that 8x and 12, there is another 2 that can be pulled out. 2 groups of 4x is 8x, and 2 groups of 6 would make 12. Wait a second. We see it once again that 4x and 6x have a common factor of 2 that can be pulled out, because 2 sets of 2x is 4x and 2 sets of 3 is 6. And finally we get to the point that there are no common factors that can be pulled out from inside the parentheses. So if we were to, in fact, multiply all those common factors in the front out, 2 times 2 is 4 times 2 is 8. And at this point, some of you are saying, well, of course, Mr. Callan, I could have seen that from the start. You could have pulled 8 from both 16x and 24. 8 sets of 2x is 16x, 8 sets of 3 is 24. And ladies and gents, that is the benefit of being able to identify the greatest common factor. It can save you all these steps, and you can go straight to the final answer. Now again, my hint was always check what's in parentheses and ask yourself, are there any more common factors other than 1? Are there any other common factors that can be pulled out? And finally, when you get to the end, you'll notice that nothing can be pulled out of both 2x and 3. All right. At this time, if you would like to pause your video, go ahead and do the rest of the evens on this first page. Come on back when you are ready. So I'll point out for number 6, there are no common factors other than 1 that can be pulled out of 7x and 3. So we are going to write the fact that these cannot be factored. Meanwhile, for number 8, Both of those, you can have a 5 get pulled out. So we can now multiply 5 sets of 6x and 5 sets of -5. And yes, ladies and gents, you may simply write 6x subtract 5. Now in this case, you might be tempted to write 5 again. However, the greatest common factor is going to be 25. 25 sets of 2x would make 50x. 25 sets of -3 would make -75. Or you may write 25 times parentheses 2x subtract 3. All right, let's go. Number 12, 18x 13 cannot be factored. And 36x plus 45. Well, I know 3 goes into but I believe 9 would be the greatest common factor. 9 sets of 4x gives us 36x. 9 sets of 5 gives us 45. All right, if you wish, go ahead and pause the video once again. Come on back for a rapid review of the odds, numbers 5 through 13, and then we'll carry on with the back page. Pause video, come back when you're ready. 5 groups of 3x plus 2, 3 groups of 2x plus 3. Number 9 cannot be factored. 6 groups of 4x minus 3 and 4 groups of 4x minus 3. If you wish, pause, rewind the video. The rest of us will carry on to examples on the back page. Here we have kind of a awkward, I will admit, but an awkward real world situation that might involve factoring. Let's say we have a rectangle. The rectangle is an area of 4x plus 6 square units. The width is 2. The question is asking what is the length. So I'm going to go ahead. I'm going to draw a nice little rectangle here. And I'm going to write in the middle 4x and a positive 6. Now, just kind of imagine this split up. So you got 4x's on the left side, positive 6 on the right side. P.S. It says its width is 2. So really what we want to know is the length. I'm going to go ahead and get rid of those. And I'm actually going to split up this rectangle into 2 rows. So imagine, if you were to split up 4x into 2 parts, then one part has to have 2x and the other part has to have 2x. I should have done that in green. So 2 groups of 2x's will give us those 4x's. Meanwhile, if you're splitting 6 up into 2 parts, naturally there would have to be an additional 3. Please notice that what we did was we essentially took 4x plus 6 and we split it into 2 factors. A length, well, I'm going to go backwards here. I'm going to call it a width and a length. They told us what the width was, so we had to come up with that length. And in so doing, we found that length to be 2x plus 3. Now, since the question is simply asking what is the length, we're going to go ahead and write our answer as 2x plus 3. Let's see, does it say inches? Does it say feet? It doesn't say anything, so I'll just go ahead and write units. Not square units, not cubic units. We're just talking about a one-dimensional length. All right, told you, a little awkward, but nevertheless, really any problem on the front side, if you're struggling to factor it, you can go ahead and draw yourself that rectangle and say, how many rows could I split this up into? Onward to number 16, or tell you what, if you want, pause the video, see how number 16 is similar, see how number 16 is different. Come on back when you're ready. Rectangle here, area 9x plus 12, width is 3x minus 4. What is the length? That's what the question's asking. Drawing another rectangle, 9x's, and I'm going to go ahead and write a negative 12 here. Now, interesting in this case that it actually gives us a width of 3x and a negative 4. So, how many rows would we have to split that in for each portion, each piece, to have 3x's? Well, not surprisingly, 3x, another 3x, another 3x. I guess that means I need 3 rows. -4, another -4, -4. Yep, 3 -4s does give us -12. So what we essentially did was we took 9x and a -12, and we factored it into a length times a width. In this case, they actually gave us the width of 3x and a -4, and we had to come up with the length. So our length we're going to write still does not say inches, feet, meters. So let's go ahead and write units. You see how those problems are similar? You see how those problems are different? Again, any factoring problem, including those ones on the front side, if you wish, you could go back. If you're getting stuck, you could draw a rectangle. You could say we got 6x, we got 10. What can we pull out of both? Well, we can pull 2 out of both. 2 sets of what? Well, 2 sets of 3x will give us 6x, and 2 sets of 5 will give us 10. And that's one way of doing the factoring visually. All right, onward to number 17 and 18. For number 17, we have a square picture frame. Perimeter is a key mathematical word. 20x plus 32, I should have circled the inches along with it because we always include the units. Question, what is the length of one side? So in this case, be careful how you draw this. We're not drawing simply a rectangle. We're drawing a special rectangle. We're drawing a square. Now, I'm not going to put 20x plus 32 into here because actually they give us the perimeter. And to find the perimeter, we simply add up all the sides of any polygon. In this case, though, we have 4 times the length of the side. Okay. Oh, I didn't need to do that. I could leave that up for just a moment. Now let's see what we know. We know what the perimeter is, 20x and 32. We know we have 4 of these. We simply don't know what this is. Aha, how about undistributing? How about coming up with a factor? So if we were to split up 20x into 4 parts, 4 groups of 5x would give us 20x, and 4 groups of what would give us 32? That would have to be 8. And therefore, the side length of each part, well, the side length of the square, since all the side lengths are the same, are congruent, will be 5x plus 8. Oh, in this case, it actually gives us a unit. So we're going to write the side length of this particular square would be 5x plus 8 inches. If you don't believe it, you can always go back to the picture. 5x plus 8, 5x plus 8. You could add up all the x terms to get 20x. You could add up all the 8 terms, and that would give you 32, and it would check out. All right, one last one. Go ahead, do number 18. Pause the video. Come on back when you're ready. So essentially, we are asked to factor 4x plus 36, and we're given the rectangle as a way of helping us. What could be pulled out of both? I know, yes, they're both even, but 4 would be the greatest common factor. In this case, 4 sets of a single x would give us 4 x's. I'm going to go ahead and not write the 1 this time. And of course, 4 sets of 9 would give us 36. So that's really all they're asking us to do, folks, is to factor it out. So make that connection to what we have been learning in the past. We've been learning the last few days about least common multiples, and before that, greatest common factors. Again, we're looking for factors, only now we're looking for factors not just from one number or 2 numbers, but from an expression. Actually, I'll tell you what we did before. If you take a look at this, what we did a couple days ago was we looked for the greatest common factor of 2 terms. Now we're just combining those terms into a linear expression and saying, okay, what times what? So go ahead and complete the rest of the assignment, ladies and gents. I didn't put a lot of space on the worksheet. I'm hoping you'll just write your work in the notebook like we always do. This is assignment, well, whatever the assignment is, whatever the date is, go ahead and continue this in your workbook, in your notebook, and let me know if you have any questions. Take care, folks. Let's grow.